Hi, in this tutorial, we're going to be covering what a material is, what a shader is, and what a texture is. Those terminologies seem to get sort of thrown around, and especially by new people into the industry, it's not understood as to exactly what those mean. Software also sometimes kind of complicates it because they tend to intermix some of those terminologies and not necessarily use them in a way that would allow the user to understand them directly. Now, what I have is a quick example of some different materials that I've put together. We have carbon fiber on the left with like a candy coating over it, sort of like a car kind of carbon fiber thing with a real shiny surface on top. Wooden floor type material, it's a little worn, not very shiny and whatnot. Then a brushed metal, something that's, you can see that it's not super shiny and it's shiny, but it's not super clean kind of thing in the way that it's reflecting light. Really bright chrome, polished, chrome kind of sphere. Plastic, it's shiny, but it's got this sort of dull, soft look. It could even be like an ivory kind of look. The next one along is a skin shader. Now, skin shaders have a whole unique property altogether that we're going to quickly discuss too. Glass, of course, something unique about that, where it is refractive, reflective. Light can pass through. In fact, you can even see that the shadow behind it is duller. It's not so dark as the other ones. The one on the end is a multi-submaterial in this case, where there's multiple of the other materials applied to a single object. So you can apply materials onto given faces. Now, what we're going to discuss now is what the difference between those three terminologies are. So to do that, I'm just going to bring up the material editor in 3ds Max, and we can discuss those. Now, I'll press O and bring up my list of all my material map browsing. So first off, what is a material? Well, a material is a combining of all of the other two essentially. So if I go in and load, for instance, the carbon fiber here, we can see that we have the carbon fiber loaded. I'm going to move this whole thing, by the way, and if you didn't know, Control Alt and grab the parent, and the children will move with it. I'm also going to take these and collapse them down. You can see there's a lot of inputs and outputs that aren't being used. I'm just going to grab them all and hit H. And then I'm going to right click and say Layout Children so you can see this a little bit better. So the combining of all of the parts, this becomes a material. So this in itself is material. Up above, you can see I have another material. So essentially, a shader with inputs, which are textures or utility nodes of some type, produces the material, so the overall material. The shader itself is just a single node in a sense. So in this case, I dragged out the physical material that comes with 3ds Max. And this physical material then is designed to actually handle how light interacts with the surface. That's what the shader is doing, is it's understanding how light is to interact with that surface. So if we go back and have a look at the different materials I have here, we have different properties to them. Things like the sort of the carbon fiber idea. I've actually got this candy coating over the top that's smooth and shiny. So we get these nice clean reflections, but underneath is a bumpy carbon fiber surface, which is really carbon fiber is made out of fibers of carbon that are woven together into sheets. Okay, basically it becomes a cloth for all intents and purposes. So it's very bumpy, but it's got this candy coating, so it's reacting to the light by reflecting quite a clean reflection off of it. The wooden floor has got these micro bumps in it, and so it's got cracks and crevices where the light can enter and it kind of gets trapped. It bounces around, and by the time it comes back off the surface again, it doesn't have much energy to it, so you don't get hot highlights. But something to note, all surfaces reflect light in some way, form, or another. Okay, it's just that they do it more or less depending on certain properties. And in this case, in the wood, it's those cracks in the wood. It's the unevenness of the surface that's scattering the light back to the eye, so you don't get these perfect reflections. The next one along that metal and the forest. So these two metals then, this one has more sort of surface cracks. It's got more of the roughness to how the reflections are being returned. So you don't see a perfect reflection of the environment around. And the next one around, the chrome ball, has just very, very fine sort of lines and cracks to it. If you had a perfect reflection off there, what you've effectively got then is a mirror, okay? And the reflection is coming back very, very clean. Whereas even in a steel ball like this, there's going to be very fine micro sort of roughness to it that is scattering the light just enough that it doesn't produce that perfect reflection. Plastic has a little bit of properties of absorbing the light somewhat. It's not a super hard surface, so it's got those small sort of inconsistencies in the surface, but it is fairly reflective overall. Skin has a whole other property to it, and skin, or let's say candles and candle wax type thing, actually allows light to pass through it. This is referred to as subsurface scattering. So when you look at the color of your color of your skin is determined by the light actually entering the surface of the skin and bouncing around inside your skin and then exiting again. Now, of course, a lot of light is absorbed at that time and trapped inside of the skin and doesn't exit, but enough of it does that it pulls up, the reds underneath your skin, or birthmark or whatever else. And of course, if you've got very dark skin, those pigments trap the light even more, so you don't get as many sort of the light passing through as much. This is why somebody who's dark skinned doesn't get sunburned as quickly as somebody who's very fair skinned, for instance, is because their skin is able to sort of not let the light penetrate as deeply into the surface of the skin. Whereas in this case, you can see that the light is actually passing through. Now, I have a light directly above this object to try and get that feeling, but you can see that light is spilling out down around the edges, and that's because it's trapped inside the surface and bouncing around and eventually comes back to the surface again. The next one's glass, and of course, glass has got reflections and refractions. It's very shiny, but light can pass through it. Again, as you can see, the shadow isn't as pronounced. It's picking up a little bit of the color. And of course, if Arnold was, able to do it, which it's not, unfortunately, we would probably also see in this case caustics, which is where the light produces patterns onto the ground, sort of like a glass of red wine on a white countertop with the sunlight passing through it, or going into a pool and seeing those cool patterns on the bottom, or them reflecting all over the walls of the of wherever the pool is. Those are caustics created by the light refracting through the water and then causing these patterns because of the light's being deviated and sort of focused in some areas by the water surface changing. And of course, the last one is a mix of multiple, as we mentioned before. So let's have just a quick look at some of this then. So let's take a look at a couple of the different materials that I've created in here and how they differ and how I've built them. So I've loaded up four of them that I have. We'll start with the first one here, which is the carbon fiber weave. Now I've also closed up all of the nodes for these, so we could hit H. So if you wanted to see what they all are, we have a couple of different things happening here. You'll notice I'm using three of the inputs only at this point. I'm using the base color map, which is the color of the object, roughness, which controls how rough that surface is at the micro level. So those are those micro fine scratches in a surface that are helping diffuse the light as they bounce off the little cracks, and the reflection doesn't come back in that sort of perfect mirror-like fashion. I'm using a bump as well, which is also helping with that effect because it's producing, sort of a fake bumpiness to the surface that's also allowing the light to reflect in different ways. Okay. So in this case, what I'm using is actually three nodes that are being put in. This is referred to as the shader. So this is the shader. Then these are texture nodes that are added. Now you could think of some of these like sort of utility nodes that are being used. This is the texture in itself. This is a procedural weave material. So when I say procedural, this weave texture is being generated mathematically. And with OSL, you can see that by clicking on the magnifying glass, and you could actually go in and edit this code if you like, or change it, or write your own, download your own, whatever you like, to be able to get more nodes and whatnot in OSL. So this is generating that carbon fiber weave. Now to be able to scale it and whatnot, we could use the scale factors here, but what I've also used is a utility node, and this is the UVW transform node, which can be found, by creating maps, OSL, and underneath UV coordinates, UVW transform. And what this allows us to do is have an input that controls all of the UVs, and you'll see where this can become handy in further materials as we get down below. Now I'm controlling it, and effectively here I'm going in and rotating the texture because there wasn't any way to actually rotate it at this point here. So now once it outputs, I have multiple outputs I'm using. I'm using the color straight out of the weave, but for things like the roughness, I wanted to be able to control it and make it look less rough. So in this case, I used a color correct node, and I color correct it and push the brightness down, sorry, brightness up, I guess, so that it ends up with a brighter looking texture and telling it it's going to be rougher. And then I've got the bump coming out as well, and I can control bump properties right here, of course, in the shader itself. Now that's a relatively simple one. If we move down, we can see one that gets a little bit more complicated. In this case here, we have the same physical material again, and so all the same properties, but one of the things I'm now using is subsurface scattering. So this number, is being turned up, but I have a map controlling the color. And what that's doing is it's allowing the light to pass into the surface now with the subsurface scattering and bounce around and return some sort of scatter color. Now, what I've done is the same kind of idea. I have a UVW transform node so that I can scale the UVs. And I have, in this case, an OSL bitmap that I'm loading. And the OSL bitmap lookup, and I've got two of those. One is for the diffuse texture, and one is for the normal map. And this is where the UVW transform node comes in handy. If I had done it the old-fashioned way, I would have had to have changed the scale of the textures in both of these and tried to keep them the same. Now, that can become a problem. There is ways with the old bitmap node of dealing with that, but it's not nearly this convenient. In this case, I can create one transform node and just plug it into both. Changes in one now affect both of them. Another color correct, so I can do some color corrections on it. And a color correct again, why I did it this way I'm not sure, but essentially I wanted to have the base color a little fainter, and I wanted to have the SS color, so the subsurface color, to be brighter. So if you were to look under your skin, you'd obviously have a lot more blood and a lot more gore going on, right? So we need a little bit more, saturated colors coming out for the SSS for it to look right. I also then did a color correction for a roughness map, so I could play around with the roughness settings to make sure that the roughness came out the way I wanted. And of course, the normal bump node. And you could think of these as utility nodes effectively, that allow us to be able to manipulate the textures that we're using. So this physical materials allowing the depth and everything else, and the light to penetrate into the surface. Now, the next one down I actually have is my glass, and that is this glass material here. And you can see that there are literally no inputs whatsoever. It's just strictly glass. So in this case, this is not only the material, but it's also the shader itself. So that's why these are called materials. It is a material into itself because it already has these inputs that can be utilized, and we can adjust these as is. So you can see the roughness is at 0. This is a super shiny surface. It's not rough at all. It's a polished glass. Transparency is turned all the way up so that we can see through it. And we can set a depth or a thin-walled parameter. You've got subsurface has been turned off. Emissions, if you want to use those in materials, will allow them to glow, actually emit light. So this is a very simple material. Now, there is also all of these presets, and you can play around with these. And this is how I got this one. I just simply said solid glass, and voila, I had all the solid glass settings, and it was plugged in for me. The final one looks a little bit more complicated, but it's actually not. What this is this one on the end that is a multi-sub material. IDs have been set using this edit poly modifier. This stack should probably be collapsed for this reason. But if you can see, if I turn it off, it just goes back to being solid chrome, because that's the, the one of the original ID for it. So this is sort of like it's not a shader unto itself, but it's another utility node that allows multiple shaders to be plugged into a single object. So this multi-sub material with its IDs has been applied into that object. And then each one of these is simply a copy of the other ones that I've created along the way. So you can see that these are all the different material trees that have been input. So understanding the terminology is going to help you understand what you're after, and then understanding the properties of what you need to change to be able to mimic any kind of material that you're looking for. Effectively, any material can be generated in 3ds Max or other DCC applications, as long as you understand how to manipulate the shader and how to input the right types of textures and utility nodes to be able to control it.